This is the Voyager 2 space probe, approaching Neptune, the furthest planet in our solar system. It was the first time that any spacecraft had made the 4 billion kilometer journey, and very little was known about this gas giant at the time. Neptune is so far away that it has only completed a single orbit of the Sun since we discovered it back in 1846. The true scale of our solar system is impossible for us to comprehend, and due to the laws of physics, navigating this huge expanse is anything but straightforward. Nevertheless, in August 1977, the Voyager 2 space probe began an incredible lifelong journey that would take it all the way through our solar system and beyond. Today, the space probe is some 20 billion kilometers from Earth. But how did it get to this point? In the mid-60s, a NASA engineer discovered a rare alignment of our 4 biggest planets was about to take place. This alignment only happened every 175 years, and it would allow a spacecraft to visit all 4 of these giant planets in a single mission. And so, it was up to Voyager 2 to take on this challenge. But in order to get there, Voyager 2 had to thread the needle through space, perform 4 gravity assists, and escape the Sun's gravity. The planets in our solar system are constantly being pulled in by the Sun. But since they are also moving sideways very quickly, their motion fights against the Sun's pull, keeping them in a constant orbit. Without this velocity, objects in space would simply be dragged straight into the Sun. But if an object is traveling fast enough, it can outpace the Sun's pull, allowing it to completely break free and travel beyond our solar system. And so, Voyager 2 needed to go fast enough to escape the Sun's gravity. The closer an object is to the Sun, the more it will get pulled in. The Sun's gravity creates a deep well in the fabric of space, which we can essentially think of as a hill. An object trying to escape from the bottom of the hill will need much more velocity than one escaping from the top. Since Earth is still relatively close to the Sun, Voyager needed a lot of energy to escape. None of the rockets around at the time were powerful enough to do this. But due to this incredible alignment, Voyager could use gravity assists to slingshot itself from planet to planet, increasing its speed along the way. In order for Voyager to leave our solar system, it had to exceed the Sun's escape velocity, which at the distance of Earth was about 42 kilometers per second. Despite launching on the most powerful rocket around at the time, it could only provide a delta V of around 10 kilometers per second. This may not sound like a lot, but Earth was already moving around the Sun at 30 kilometers per second. So by launching Voyager in the direction of Earth's travel, it took advantage of this velocity, allowing it to reach around 40 kilometers per second relative to the Sun. This was enough to escape Earth's gravity and place it into a very large orbit around the Sun, one that would take it well past the distance of Mars. Under normal circumstances, it would remain in this orbit indefinitely. But since it was trying to get a gravity assist from Jupiter, it aimed itself at the point where Jupiter was going to be by the time it arrived. However, despite the sheer scale of the area around Jupiter, Voyager had to thread itself through a very narrow 150-kilometer wide corridor and arrive at a specific point to the nearest second, all whilst traveling at 10 kilometers per second. If Voyager missed this point, or was a few seconds off, it would have ruined the gravity assist and its following gravity assist around Saturn. In order to plot its trajectory, NASA needed to know how fast it was going. They did this by sending a signal out to Voyager and timing how quickly it would respond. Since each signal traveled at the speed of light, multiplying these 2 numbers would give them Voyager's distance. Then they'd send another signal, which would give them Voyager's new distance. By subtracting these distances, they could figure out how much Voyager had traveled in that time. With this, a simple calculation would tell them how fast Voyager was traveling. With all of these data points, NASA could continuously plot Voyager's trajectory and see how it compared to the desired trajectory. If the space probe was a bit off, they could send a command to Voyager which would fire up its thrusters to fix it. With this incredible system, Voyager arrived at its Jupiter target point just 1.4 seconds late, and only 60 kilometers off course. As Voyager 2 approached Jupiter, its speed had slowed considerably to around 10 kilometers per second as it reached the top of its orbit. This was now well below the Sun's escape velocity, which, at Jupiter's distance, was around 18 kilometers per second. But as it got closer to Jupiter, its gravitational pull started to have an effect on the space probe. Since Jupiter was already moving very fast in this direction, it pulled Voyager in and essentially multiplied its current speed with Jupiter's speed, sending it off at an even greater velocity. Voyager was now going faster than the Sun's escape velocity, and from this point onwards, it was destined to escape the solar system. But the journey wasn't over yet. Voyager went on to complete 2 more gravity assists around Saturn and Uranus, making incredible discoveries along the way. The final gravity assist would be around Neptune, but this gravity assist would go a little bit differently. Since there were no more planets to visit after Neptune, Voyager didn't have to follow any particular path around Neptune. However, scientists were very interested in flying as close as possible to Triton, one of Neptune's moons. But Triton orbits at a steep angle, and so getting close would require a dramatic change of direction. And so, instead of approaching from behind Neptune, Voyager approached just a tiny bit in front, heading over the planet's north pole. This was enough to bend Voyager's trajectory downwards, whilst also slowing it down. 5 hours later, Voyager flew past Triton, and from then on began its lifelong journey into deep space. This epic journey took 12 years in total, and the discoveries that Voyager made along the way taught us an incredible amount about our solar system.